Okay, I have the fan slid on here just with friction. There's no rivets in there yet. Just to give it a real quick check here. Okay, now as I had that friction fit before, I don't want that friction fit. I have to have this a little bit looser. What happened is, when I machined that, I machined it and I tested it on the top side here, and it fitted over properly. But it gets down to the bottom here, it's a little bit tighter, and that's why I had that friction fit. But I put this back on my lathe again, and I took it down. It's a little bit more, so I have some room in here to move that around. So now it drops in there fine, comes back out. So the reason why I did that there is so that when I go to line this up, I have some room for this to move back and forth to line up properly. So everything's concentric. Okay, so now what I'm going to do is I'm going to put this fan in my 4-jaw chuck, and I'm going to indicate that in and get that zeroed in now. Okay, I got it dialed in as best I can here. Got a couple thou off, but I think a lot of it has to do with the rim itself too. It's a little bit of bumps here and there. So on the average, I've got it pretty well indicated in. And so now what I'll do is I'll set up my fixture here now to put that piece in there. The actual flange bushing, to put that in there now, and then I'll put a little glue in here, and then we'll push that in there and get that glued up, and then be ready to do the drilling for the rivets. Okay, here's the setup. I have my the fixture shafting here. That will go in here, and I will tighten that up later on, and then I will slide the actual workpiece on like this. I'll then put a little bit of glue, maybe in here and on here, and then I'll slide the whole fixture in. On the tailstock, I'll tighten this up a little bit to keep everything concentric, and then I'll just keep on sliding in until it makes contact. And then let it sit there until it dries, and then see how that works, and then I'll be able to take it out and then drill it and put the rivets in. So that's the setup I'm going to use right there. So now I'm going to get this things in here proper and get everything lined up properly, and then I'll fit it in there. Okay, I'll put some of this here Zap super glue on the rim here all the way around, and then I'll put it on there. I'll set this on the fixture and slide it in. Hold it nice and tight now. And I did make sure that it's unplugged, my lathe's unplugged. Okay, I'm going to let that sit a little bit now, and we'll see how that works. When that glue holds up, when that sets properly, then I'll be able to take it out, and I'll make a little fixture to hold that while I drill that, because I have to drill that on my rotary table so I can get it nice and concentric so that the rivets are in the proper place so they won't be out of balance as well. Okay, so this is how far I got so far, and so that's all I'm going to do for right now. Okay, the first time the glue that I used at their Zap glue, it's kind of old glue, and it didn't hold too well. So what I did was I re-indicated in the scroll cage again, and then I put some contact cement on the shaft housing on the workpiece, and then I slid it in and I made it real tight, and I kept it in there for about a couple hours now. It's been there about a couple hours. So now we're going to pull it out and see how straight it stays. That looks really concentric. That's very nice. There's no that hole is moving nice and even all the way around. Okay, that looks like a good job done on this here then. I'll just double check here before I take this out and make sure that it is tight in there, and then it'll be ready to start to be riveted. Okay, here's a good test right here. Let's let it roll down on the surface plate and to see how even that there everything stays together here. Okay. Alright, so the next part of this project now will be to get this on the rotary table and get it fixed nice and tight, and then drill. And the reason why I'm going to use the rotary table is because I want to make sure that the rivets are in the proper position, 90 degrees from each other. so that there's no offset counterweighting going on or anything. Everything would be even weight all the way on all four sides. I'll start that later on. Here, I'll put this on the rotary table. But I'm very happy for how that's staying out like that. It came out pretty nice, came out real nice. And our fixture worked really good for that. Building that little fixture here. Used it as a press. That worked out really nice. Okay, so that's how far I got on this here so far. Okay, the next thing I'm going to do now is put this on my rotary table. And I'm going to drill down through the front here if I can. But I have to get some dimensions here so I know how far I can come in to drill and to get the rivets in there lined up properly. Okay, the reason why that I need to set up my rotary table is because I need to make sure that whenever I put the rivets in here that they're equal distance from the edges and they're in the right circumference with each other, in relation to each other. If I were to just go with the table movements X and Y, that doesn't guarantee it I'm going to be able to get it 90 degrees. I need to make sure that the rivets are opposite each other and they have to be 90 degrees from each other to keep everything balanced. And that's why I'm using the rotary table to drill these here holes for the rivets. Okay, the first thing I did was I clamped down a board. This will be a backing board here, so my drill bit will come through and doesn't hit the table. Also, this is going to be used for a line-up fixture also, and I'll show you what I mean by that whenever I drill a hole in the center here. Okay, the first thing I'm going to do is I'm going to take a 3/8 inch end mill, and I'm going to drill down through here as a locating hole. The reason why for the locating hole is because just in case this board should move or something, or if I need to bring the table back in position, back to center of the rotary table, I can use this here hole as a location hole to center everything back up again. An example of being used right here, put a 3/8 inch piece of bar stock in there, and that's how I'd use it to line it back up again. If I should need to line this back up again sometime in the future, I can do it this way here, using this bar here, right here, to line as a line-up tool with that hole, the locating hole. Okay, now I'm going to start putting, I'll put this here part on here now, and get that established. But before I do that, I got to get some tape on here, in order to get that to fit on the rotary table. Now I'm just using an old end mill right here that upside down to use the shaft of it as the line-up tool. But let's just see how close this is as far as being lined up on center now. Whenever I just drop this here out, here, see if it lines, how well it lines up. Alright, that's good. It went right into the hole, so that's lined up really good. Alright. What that means is that the hole was drilled pretty accurately on center. It wasn't oblong or anything. It's to be able to drop that straight in there from that height and to line up properly. So I know now that's a good lined up hole there. It's a good locating hole. I need to get my zero position on the rotary table. I need to get some tape on here. And then I need to line this up using the shaft here in the mill and get everything lined up and taped down, and then be ready to start drilling this for the rivet holes. Okay, first thing I'll do is I'll put my shaft fixture back in there again. And I have some double stick tape on the fan housing here now. I'll line this up on here, and then I'll bring everything down. Let everything drop and push it down in place. Alright, that drops in there nice too. Okay, now ready to set up for drilling. Now before I do any kind of drilling, I don't want to rely on the tape itself to hold that, even though I'm going to be drilling carefully. I'm going to clamp this now to the table, and I'm going to clamp it in such a way where I can drill 180 degrees from each other, and then turn it, and then clamp it again and drill it. And that way there it'll stay nice and tight by clamping that. So I'm going to get some way of clamping that first. Okay, now I got everything clamped down 180 degrees from each other as best as possible here. I now have to get myself an opening that I can be able to get my drill bit down inside here now, in between these clamps. And I also need to make sure that I'm getting 180 degrees from one drill to the next on the other side. So what I want to do is I got this turned so that I can traverse my x-axis where I need to get it to drill inside here now. And plus I got enough room between the clamps. However though, here's what I need to do. I'm looking on my rotary table gauge here, and I need to get lined up here on some specific number, because when I got that number, I'm looking at 180 right now, by using 180, that means then once I drill this on this one side here, then I can turn the rotary table again 180 degrees off of that to drill the other side, and that way there both holes will be concentric with each other in the same circumference and 180 degrees opposite each other. And then once I get that, then I'll figure out how I want to re-clamp it so I can drill 90 degrees from each other. If I can do that there. If I can't re-clamp it and do that, then I might just have to go with just 2 rivets only. But I'm going to try to go 4 if I can by re-clamping, but I'll see how that works whenever I get to that point. Okay, right now I want to start traversing now the x-axis to get where I want to line up here with the drill bit now, inside here now. Okay, doing some calculations here. It looks like it's going to be 563 thousandths, and that's going to be traversing my table x-axis 563 thousandths, and that would be from the center of the bore here to the center of the flange right inside here. The center of the flange, that's between the edge here and between the fan blade. So that would be the center right here. And I got a center finder in here right now that I can use to double check that. So I'll traverse my table now, looking at my dial indicator 563 thousandths, and see where that ends up at on the flange here. Okay, I'm 563 on a dial, and there's my center finder coming down. Let's get a light here. And that looks to be pretty much on the center of the flange. That's what I need right there, right in the center of the flange. Look like we're there pretty good. Alright, that's going to work good for there, so I can now set up here and start getting ready to drill for the rivet holes. Okay, now I have my X and Y axes completely locked. I have the rotary table completely locked. I have the, here's the most important part here. I have this set at 180 on the scale, so I have that number recorded. That's locked in that position, 180 on the number. And I even got rid of the backlash here on the handle and got the number 0 lined up here and a 0 here. So I got all the gauge numbers set up, located. All the tables are locked, and everything's now ready to be drilled.